In this problem, we're given the function f of x is equal to 8e to the negative x minus x plus 10 over 5. We're asked to find the roots with Newton's method, and I've written out the formula for Newton's method here. X of n plus 1, or sub n plus 1, equals x sub n minus f of x sub n divided by f prime of x sub n. Okay, and I've also graphed this in the calculator to sort of get an idea of what I was working with here. Here's the graph. So you can see that the root, the only root, happens around 1. Okay, it happens around x equals 1, somewhere in that area. So that's where we're going to start. We're going to say that x sub 0 is equal to 1. Okay, and for this formula, we also need the derivative, because the derivative is part of the formula. So we need to find the derivative of f of x. So let's write that down. F prime of x, and we'll do this term by term. So the derivative of 8e to the negative x, the negative x in the exponent makes the 8 negative e to the negative x. All right, so the derivative is typically itself on e to the x, but since it's negative, that's going to make the derivative negative. Okay, and then x plus 10 over 5, you could also write that as x over 5 and 10 over 5 if you wanted. The 10 over 5 is a constant, so that's going to go away. The negative x over 5 will become minus 1 over 5. Okay, so that's the derivative, and we now need to start using Newton's method. Okay, assuming that x sub 0 is equal to 1, how do we find x sub 1, which would be x sub 0 minus f of x sub 0 over f prime of x sub 0. Okay, so how we're going to do that, we know x sub 0 is 1, so minus f of 1 divided by f prime of 1. Now you can plug that in and get an answer, and it'll be a decimal answer, but I'm going to show you a way that it can be done in the calculator, and once you do it this way, then you can keep doing the next iteration over and over again pretty much instantly. Okay, so how do we do that? Well, first go to your calculator, and in your calculator, let me turn on the lamp so you can see this. In your calculator, you type in the original function f of x in y1. Okay, it's the original function, and then in y2, type in the derivative function. Okay, so we have both the original function and the derivative function. And when you exit out of that, go back to your main part of your calculator, first type in whatever your x sub 0 value is. Okay, so our first value that we're guessing at where the root is, we are guessing that the root's at 1. So type in 1 and hit enter. Okay, then we're going to type in this formula, but we're going to use it or do it using answer. Okay, so we know the answer that we just got was what? 1. Okay, so that serves as our x sub 0. So instead of x sub 0, I'm going to type in answer minus, and now I want to type in that answer, that 1, into the function. I do that by going to vars, go over to yvars, hit enter on function, and we had the function typed in y1. So we hit enter on that, open parentheses, and then second negative sign gives you answer. Type that in, and now we want the bottom part here, which is the derivative. Remember, we typed that into y2. So divide, go back to vars, yvars again on function, and this time do y2 of answer. Okay, so before I hit enter, make sure that we understand where this comes from. We typed in a 1 so that we would have our first root, so that way when we hit answer, it's a 1. And this and this and this are where that answer needs to be plugged into in order to get the next answer. Okay, so we plugged in an answer for x sub 0, x sub 0, x sub 0. This is being plugged into the original function, and this is being plugged into the derivative function, and that's the formula for Newton's method. Okay, now when we hit enter and we get an answer of 1.2364069, now when we hit answer, it's going to be that number. Okay, so we can hit second enter. Well, let's hit second enter again until this pops up, which is the same formula we use, except this time the answer that's being plugged in is not 1, it's 1.236, all those numbers. Okay, so when we're doing Newton's method again there. We hit enter, And so our next iteration, our x sub 2, write that down here, is equal to 1.2665744694. Okay. And now if we want the third iteration, hit second enter and enter again. That does it again using the previous answer. So 1.2670011161. Do it again, second enter, enter. And we can just keep going with this as many iterations as you want to write down. Let's do one more. Okay, now as you start getting closer and closer to the actual root, your calculator is going to stop changing answers. Okay, so you realize that the last two answers that we got, the fourth iteration and the fifth iteration, are exactly the same. At that point, there's no real use in going on because your calculator is not going to be able to get you any closer to the answer than however many decimals that is. It looks like 8 decimals, 9 decimals. Okay, 8 or 9. Let's see. 9 decimals. Okay, and you can stop there. And so if you want 10 iterations, you just keep hitting second enter and enter again, and it gives you the next iteration. It speeds up the process significantly. So we are saying that this right here is the root, the one root of this problem, the 1, 0.